let's get into the meat of this. What's actually happening? So we're going to be talking about the workflows, what you call contracts, not prompts. So walk me through your actual AI workflow. So what did you figure out that others have not with regard to LLMs for embedded systems?
Well, what I started doing pretty early on was creating some documents that the LLM can reference that will provide it with all of that context that I was just talking about. So, so if for the LLM to be useful for producing code on an embedded system, it needs to know what is the hardware platform that it's running on. What is the SDK that it's running against? What versions of different things are there? It needs to know a hardware map of what's connected to what pins on this particular processor in this particular product. And so all of that context is relevant and necessary for it to produce useful output, but that makes for very long, complicated prompts and prompts that sort of fall out of context the more you get into a session. And so what I started doing was using a series of documents, and some people are kind of familiar with this model. A lot of coding and even other uses of LLM use this, where there's like an agent's markdown file which has some instructions for the LLM agent. But what I will do is let me share my screen and we can start kind of going through. So So, so this, what I'm showing right here. So this is a kind of a generic uh, agents markdown file that is kind of the starting point for the LLM. And this was derived from a project that I've been working on for a while. I scraped out all of the project specific stuff to make this a little more general for our discussion purposes. But typically, when I start a session, it starts with a starting prompt that looks something like this. And so what this does is it tells the agent to, first of all, to use the agents.md markdown file, as well as some additional documents that we'll talk about, to review handoff, which is a critical part of this as well. And then in this case, it's identifying 3 active code locations. This particular project involved 3 different programmable components, and each of them had a specific location. It has some information about how to reference them. And then where the sort of the critical pieces come after this, where it says, okay, for every code change, this is what we're going to do. So every time a code changes, it goes through and runs a full build. It makes sure that it can build the code successfully, and if not, explains why. Because there's 3 different programmable elements, it does it for all 3 of them. It also updates the handoff document after every chat turn. So every time, even if it's something small, it updates and maintains that handoff document. In this case, because I also use it for troubleshooting and analyzing logs, it reopens the log files each time. And essentially, this is telling it these are the other documents that you want to look at and use as you're processing and as you're working. And so, and then the agent's markdown file, which is the first thing that it will access and start looking at, essentially goes through and says, okay, this is how you're going to work. You're going to produce something. And when you do that, then you're going to build it, you're going to report on it. These are the things. And some of this, there's, I guess you could say, a little bit of redundancy here, but there's a reason for that. And the main reason for that is that prompts in the chat will sort of decrease in relevance within the context as the session goes on. And I think most people who've used large language models for any appreciable amount of time have experienced this, where you start a session, give it something, and the longer and deeper you go into that session, you start to realize it's quote unquote forgetting things from earlier in the session. And so the prompt is limited in its capacity and what it can do. But by setting the stage and giving it this agent's markdown file, this gets referenced repeatedly throughout the session. And this is where it defines what is the flow, what are the things that you want it to produce, and what's the reporting, what is it that it's going to tell you each time. And a few things that I've learned using these for now 6 months or more actively every single day writing code is that I- having the large language model report is critical, and that dramatically decreases hallucinations. Essentially, if you ask something generic, the model will say that it has done it, even if it hasn't sometimes. That's part of that hallucination phenomenon. But if you tell it to do something and then to report back and tell you what it did, I have found that it does not report back and tell you that it did something if it didn't do it. It's sort of, I kind of refer to it as the lazy teenager effect,
Mhm.
where if you tell your teenager to go clean their room, they'll go and then they'll say, "Yep, it's clean." But if you say, "Okay, go clean your room and then tell me exactly what you did," then you will get a much better output from that
Okay.
than if you just give them this sort of open-ended clean your room.